Here I'm going to work out a few quick examples on the topic of roots and radical expressions. There will be a lesson that's posted separately, but this is just going through a few examples quickly, okay? So first and foremost, it says find the real square roots of each number. So the square roots of 225. There is no square root symbol written, so that means if you're the one taking the square root yourself, you put a plus and a minus, you account for all answers. You should know that by heart. So the answer is plus minus 15. Here, whenever we're dealing with a decimal, it's important to change it to a fraction to ensure that you don't make any silly mistakes. So that's 49 over tenths, hundredths, thousandths, 10 thousandths. So 49 over 10,000. Now the square root of 49 is 7, and the square root, whenever you're taking the square root of a number like this, basically what I do is square root means 2. So I'm going to break this into two groups, the zeros. So it puts 2 in each group. So that's plus or minus 7 over 100. If it were written as a decimal, that is positive and negative 0.07, but it's totally okay to leave it just like that, okay? The next example is negative 1 over 121. You just write no real solution because no number times itself will give you a negative answer. The square root of negative 1 is the imaginary number I, but the directions specifically ask for real solutions. Next, the square root of 64 over 169, plus minus again, and you should know these by heart, so it's plus minus 8 over 13. So done and done. All right, next set of examples. Find all real cube roots of each number. We're going to do these the exact same way. So the cube roots, I guess I'll leave that on the screen for you. Cube roots can be negative because a number times itself 3 times can be negative an odd number of times. So this answer over here is the cube root of negative 64. You really don't need to show this step so much. I like to write it when I have to put a plus minus, but my answer is negative 4. Same idea here. I'm going to do the cube root. Make sure every time it's a cube root, you really indicate that in the index. You have 125 over tenths, hundredths, thousandths. So 1,000 right there. Make sure if it's over a fraction, it's clearly over the numerator and denominator. The cube root of 125 is 5, and the cube root of 1,000 is 10, which reduces down to 1 over 2. Okay? Next, we have this example right here, cube root. So the cube root of negative 27 is negative 3, and of 216 is 6. And again, we have that 1/2, except this time it is negative 1/2. Here, I'm going to make it a fraction first. Tenths, hundredths, thousandths, 10,000, 100,000, million. So there we go. Now it's cube root, so I need batches of 3. Or not batches of 3, I'm sorry. If I went like this and said 1,000, okay, split into two groups, 1,000 right there, then that would be the square root. I want to break it into groups of 3, my zeros, so my little trick right there. So groups of 3 would mean 2 zeros. So that means the cube root of this is going to be a 1 with 2 zeros, which we know as 100. I say a 1 or a 2? A 1 with 2 zeros, so 100. And the cube root of 343 is 7. All right, so 7 over 100 or 0.07. Next, we have fourth roots. Find, oh, sorry, I had to white it out because I was getting sloppy. Find all the real fourth roots of each number. So this should be a little quicker. We have the hang of it. Fourth roots, all of them, again, is plus minus for any even root. So plus minus 2 right there. This one, no real solution. It's negative. Again, no number times itself, an even number of times, can give you a negative answer. So even roots of negatives are no real solution. Here, 81 over tenths, hundred thousandths, 10,000, 10,000. I am doing the fourth root of this. Put a 4 in the index. Fourth root of 81 is 3. You could also take the square root and then take the square root of that output, that answer, and do it that way. So over here, though, groups of 4, I have 4 zeros, so it's going to be a 10, and we'll need that plus minus right there. So plus minus 3/10, and same idea over here. If I put the fourth root over this fourth root, that's going to give me plus minus 10 over 3. So done. We have all these examples finished. Just a couple more, and we'll call it quits. So here the root is already written. So if the root's already there, you do not put plus minus. So what's the square root of 36? Well, that's 6. Here, square root of 25 over 100, and that is equal to 5 over 10 or 1/2. If you reduced it first, that would have been 1/4. Square root of 1, square root of 4, you're still going to get 1/2. Again, no plus minus. Negative out front, that can stay. Cube root of 64, that's 4. So final answer, -4. Cube root, odd root, we can have the odd root of a negative. The answer here is -3. And a couple more examples that are coming up will be these, and that'll be in the next video. We'll post that separately.